For using Cramer's rule to solve problem type 2, you're basically, when you have three equations with three variables, you can use Cramer's rule to solve for x, y, or z. So in this case, it's going to ask you to solve for y. So just some general background. When you have a matrix, you're going to use these coefficients. Coefficients are the numbers that are multiplied by each of your variables, and the number that is by itself without a variable is called a constant. Okay? So we can see that all the constants are going to be b sub 1, b sub 2, and b sub 3. We're going to think of them as our constants. Okay? So you're going to set up your determinant matrix D by basically taking the coefficients from each of your equations and putting them into your matrix. And then if you're going to solve for x, you're going to need this D sub x matrix, which basically is you're taking your x coefficients and you're replacing them with your constants from each of the equations. Okay, if you're going to solve for y, then you're going to need to use this D sub y matrix. And guess what? You're going to take the constants and replace the y coefficients. You're going to use those to replace the y coefficients. Likewise, if you're going to solve for z, then you're going to take your matrix. You're going to replace the z coefficients with the constants from each equation. Okay? And this is going to work as long as your determinant does not equal 0. Then we know that the system has exactly one solution. Okay, so to find z, we're going to evaluate our matrix D sub x and evaluate our determinant D, and we are going to get a value. Okay, and same with y, you're going to use D sub y over D, and for z, you're going to use D sub z over D. Okay, so let's see what that actually looks like. So that's all the theory behind it. So let's start with our equation that we have here, and we have no x coefficient, so that, or no x variable, so that means the coefficient is 0. So we have 0, negative 1, 1 for our first row in our matrix. And then for our second row, we're going to take the coefficients negative 5, negative 4, and 1. So we have that down here, negative 5, negative 4, and 1. And for our third equation, we have 1, 1, negative 2 for our coefficients. Okay, so that's D. So then just a little reminder here of how to evaluate this. You're going to take this first x coordinate in the first row, and you're going to multiply that by the matrix made up from the x and y coefficients in the other two equations. Okay, so that's going to go down here. And then we're going to subtract the y value in the first equation, and then we're going to multiply that by the matrix that's made up of the x values and the z values of the other two rows here. Okay, and then you're going to add the next coefficient in the first row, which is 1, and you're going to multiply that by the matrix. Guess what? We're going to use the x and the y values from the other equations. Okay, so that's going to be this matrix here. Okay, now you need to evaluate this matrix here, so you're going to remember what you do here with the 2 by 2. You're going to take this negative 4 and multiply it by negative 2, and that gives you 8, and then you're going to subtract this other cross value here, the 1 times 1. So it's going to be 8 minus 1, which is 7. Okay, so you're going to end up with 0 times 7. That's what this represents here. And then we're going to subtract this negative 1 again, and we're going to times it by our kind of little cross here. Negative 5 times negative 2 is 10, minus 1 times 1, which is 1, and so 10 minus 1 is 9. Excuse me. And then, so here's that part right here, the 9. And then you're going to add that to your 1. And then we're going to evaluate this matrix here. Negative 5 times 1 is a negative 5, minus a negative 4 times 1, which is a negative 4. So negative 5 minus negative 4 is a negative 5 plus 4, which is a negative 1. So that's where this comes from here. Okay, so remember you're multiplying down and across and then subtracting the other two values that are multiplied together. Okay, and so now we evaluate this. 0 times 7 is 0, minus a negative 9, so that's going to be plus 9, and then plus a negative 1. So 9 plus a negative 1 is 8. And this is the value we're going to use for D. So we know D does not equal 0, and we were asked to solve this equation for y, so we need the D sub y. So remember what we did. We take our D matrix, and we're going to replace the y values with the constants for each of these equations, which is negative 2, 1, 0. That's going to go right down the center here. So you have negative 2, 1, 0 here. And now we're going to evaluate this just like we did before. We're going to take our first x coefficient, bring that down. We're going to multiply it by this matrix of y, z's that are left. Okay, that goes here. And you're going to subtract. And then you take your y coefficient from the first equation here and times that by the x's and z's. A matrix made out of the x's and z's on the bottom two equations. And then you're going to say plus, and you're going to take your z coefficient from the first equation, multiply it by the matrix over here of the x's and y's that are left over. Okay? Now again, remember, we're going to evaluate these matrices. You're going to take 1 times negative 2 and subtract 1 times 0 from it. So that's a negative 2 minus 0, which is a negative 2. Okay, so then we bring down this minus, bring down this negative 2. We're going to times that by the result of this matrix. So negative 5 times negative 2 is 10. 10 minus 1 times 1, which is 10 minus 1, is 9. So bring that down. So plus 1, and then you're going to multiply these. Negative 5 times 0 minus 1 times 1. So that's going to give you 0 minus 1, which is a negative 1. Now go ahead and use your order of operation rules and simplify this equation. 0 times negative 2 is 0, minus a negative 18, so that's a positive 18, plus a negative 1, and that gives you 17. Okay, so now remember our rule was you're going to take the value D, the matrix dy, the result of the matrix D, and that gives you 17 over 8. And so our y value is 17 over 8.